In this video, we're going to introduce a couple of definitions as far as closed regions are concerned. So I should probably point out that these are going to be simple closed regions as well, but yeah, that's I guess that's important to point out here. So we'll refer to this as D for sort of a domain. D is a simply connected region. A simply connected region. If any simple closed curve within D contains only points within D. Now, simply connected region really just means that there are going to be no holes inside of the region. So an example of a simply connected region would be the region D, which is going to be all of the points within the xy plane, such that x and y are both between -1 and +1. So sketching this within the xy plane, we have x is -1, y is -1, y is +1, and x is +1. So this region right here would be considered simply connected because any closed simple path that I can create within here is going to contain only points that are within the interior of D. So this is simply connected. However, if I were to consider the region D, which is going to be the set of all ordered pairs x, y, such that 1 is less than or equal to x squared plus y squared, which is going to be less than or equal to 9. So this would be the sort of donut region in between a radius of 1 and a radius of 3. Felt like going for a nice thick donut today. So the points in question for this, well, really good looking polar region would be like this. Now it is possible for me to make a simple closed curve within here that contains only points that are within D, but this is a statement of existence, not uniqueness. So if I can draw a simple connected curve that contains a whole bunch of points that are not within D, then we have ourselves a region that is not simply connected. Simply, there we go, connected. So basically you have one solid region that contains no additional holes within it. And one more definition, which is going to be the boundary of a region is positively oriented. Positively oriented. Well, the way that we do positively measured angles within the xy plane is that as we rotate, we're essentially going counterclockwise around the xy plane. So if you can do that in general with your region, we would consider that to be a positively oriented. So boundary of a region is positively oriented if the orientation on the boundary is overall counterclockwise. So I'm going to start with a very, very basic example. So if we were to consider x squared plus y squared is less than or equal to 1 as a region within the xy plane, I'm going to break the cardinal rule and draw my axes first. This boundary, if we were to give it an orientation, if we were to give it a counterclockwise orientation, like so, this would be considered a positive orientation. So positively oriented curve. So we're referring to the boundary, not the actual region itself. That's why I'm referring to it as curve rather than region. Now imagine, if you will, that the orientation of this curve is actually a direction in which you are walking as you're walking this path. As you're walking, if you were to hold out your left hand or your left arm would be above the region and your right arm would be outside of the region. That's generally what I use for positively oriented. So just generally speaking, we can make a nice weird looking thing like this. Now overall, I realize that we're not always necessarily going clockwise or counterclockwise here. But overall, if we were to take on the same mentality as we did for the last one and consider this to be a walking path, then walking in this direction would put my left arm over the region and my right arm outside of the region. This would be a positive orientation. Now, if I were to do something similar, but this time say I'm going to walk in this direction, my right arm would be over the interior of the region and my left arm would be on the outside. This would be considered negative or negatively oriented curve. Now, anytime you're interested in reversing the orientation on a curve, like if you were trying to set up a line integral, the line integral over a curve C of, whatever you happen to have, f of xy ds, for example, if you wanted to reverse the orientation of your curve, the reversed orientation we would consider to be negative c, and that would also negate the value of the actual curve that you're working with, or the actual integral that you're working with. So anytime you're interested in reversing the orientation, it's simply going to be a matter of including a negative sign.